Good morning to all. Welcome to this video. Today let us discuss about the coherent binary phase shift keying. Okay. So first let us discuss about the basic things. We are considering that the binary phase shift keying consists of two symbols, that is 1 and 0, so that we can write for the symbol 1 transmission, S1 of t is equal to A into cos 2 pi fct. Whenever the 0 is getting transmitted, S2 of t is equal to A into cos 2 pi fct plus 5. Here the pi will be getting varied over here. So this we can write that S2 of t can be written as minus A into cos 2 pi fct. Okay. So now let us consider this S1 of t and S2 of t will signals having a interval that 0 less than or equal to t less than or equal to capital TB. So now let us consider the message signal and the carrier signal. The carrier signal is nothing but C of t is equal to A into cos 2 pi fct plus 5. And for the message signal symbol 1, the value of phi is equal to 0. And for the message symbol 0, the value of phi is equal to pi. Therefore, we can rewrite this expression, that is energy bit, that is EB is equal to energy per bit. Therefore, EB can be written as integral root of 0 to TB S1 of squared of t into dt. So, we know that S1 of t is A into cos 2 pi fct dt. Since it is a S1 squared of t, we are writing it as A squared cos squared 2 pi fct into dt. And we are aware about the trigonometric relationship, that is cos squared theta is equal to 1 plus cos 2 theta by 2. So we are going to apply this cos squared theta trigonometric function in this integral, so that we will get A squared is constant and this formula 1 2 is there. So we will take this 2 outside and then integral 0 to tb. So 1 plus cos 2 theta. So we can write it as 1 plus cos 4 pi fct. Already cos 2 pi fct is there. So 2 into 2 theta. Therefore, we can write 1 plus cos 4 pi fct into dt. So therefore, we will get A squared 2 into TB plus 0. Therefore, EB can be written as A squared into TB divided by 2. And also root EB, it can be written as 2 into EB. So here A squared TB. From this we are going to calculate what is A. So A is equal to what? Root of 2EB divided by TB. So now we calculated this A, that is the amplitude of the signals S1 of t. So in the place of amplitude level, we can substitute the previous equation, that is root 2EB by TB. We know that EB is nothing but energy of signal and TB is nothing but bit duration. Okay. So now we consider the binary PSK system, and this binary PSK system consists of pair of signals, and we can represent that pair of signals as S1 of t and S2 of t, which is used to represent binary symbols 1 and 0 respectively. So with a prior concept, we can define S1 of t is equal to, in the place of A, we are replacing A is equal to root 2EB by TB, and S2 of t is equal to integral root of 2EB by TB into cos 2 pi fct plus 5. So this can be written as pi minus root of 2EB divided by TB into cos of 2 pi fct. And also we are very well understood that this S1 of t signal and S2 of t signal is under the limit 0 less than or equal to t less than or equal to capital TB. So followed by that, this can be represented in terms of basis function. that is phi 1 of t is equal to root of 2 divided by tb into cos 2 pi f ct, and phi 2 of t. So therefore s1 of t can be written as root eb into phi 1 of t, and s2 of t can be written as minus root eb into phi 1 of t for the limit 0 less than or equal to t less than or equal to capital TB. So now let us discuss about the space signal diagram of binary PSK signals. So we are aware about that the basis function phi 1 of t is equal to s1 of t divided by root e1. Okay. Therefore, s1 of t we know that root 2 into eb divided by tb into cos 2 pi fct divided by E1 is nothing but root EB. It is energy bit. Okay. Therefore, this we can simplify this in such a way. EB, root EB and root EB will get cancel each other in this equation. Therefore, we can write root of 2 divided by TB into cos 2 pi FCT. So, in binary PSK system, we can characterize this by having a signal space that is one dimensional, and that we can call it as capital N is equal to 1, and signal constellation consisting of two message points, that is M is equal to 2. So the respective coordinates of the two message points are, we can represent in such a way, that is S11. We know the formula that S11 is equal to integral 0 to TB S1 of t into phi 1 of t dt. So the value we got is plus root EB. And S21 is equal to integral 0 to TB S2 of t into phi 1 of t into dt. Therefore, the coefficient S21 value is minus root of EB. Okay. So, inverse, how we can call it as the message point corresponding to S1 of t is located at S11, that is amplitude of plus root EB, and the message point corresponding to S2 of t is located at S21, that is minus root EB. Okay. Therefore, we can call it as this is phi 1 signal space representation and this is phi 2. So, plus root EB for message point 1 and message point 2 minus root EB. So, these all are about the binary phase shift key, that is coherent detection, and this is the way we can represent the signal space representation with two message signals. So, hope you got clear understanding about the binary phase shift keying concept. Thank you all.